Okay, this is similar to the last problem, but in this particular case, we have two parts to this. We have the part where we write the function rule, basically the equation, and then we calculate for some given input value, some value for the time in minutes. So snail travels at a rate of 2.35 feet per minute, and write a rule to describe that. So this is in a sense, it's a unit per 1 minute. It's a unit rate, they call it. Every 1 minute, how far does the snail go? 2.35 feet. So we can say, if that's the case, then we would say 2.35 times, well, it depends on how many minutes it's been going, because if it's gone for 1 minute, it'll have gone 2.35 feet. But if you go for a minute and a half or 2 minutes, 36 seconds, that's going to be a different distance. So we can plug that number in for t, time, in minutes. And what is that going to tell us? That is going to tell us the d of t, d standing for the distance that the snail goes in that amount of time. Okay, so that's the function rule. Then it says, how far will the snail travel in 5 minutes? Well, 5 minutes is the independent variable t, and so we could write, and we should write it this way. We should write d of 5, meaning we're going to calculate this function rule for a value of 5 for t. 2.35 times 5, and we get d of 5 is equal to what? Well, let's calculate it over here. 2.35 times 5. And how do I know where to put the decimal? Because in the entire problem there is 2 digits behind the decimal. There's none in this number, and there's 2 here for a total of 2. So we then plot that point right there. And we say d of 5 is 11.75 what? 11.75 feet. That's how far the snail is going to go in 5 minutes. So we are looking for both this for the first part and this for the second part. And you might not see d of 5, you'll just see the number 11.75, but that is d. We're done.